Alright, let's open up to your table of contents, and we are already to number 15. And for number 15, I want you to title it Similar Shapes. And go ahead, look and see what page number in your note. I'm already to 31. Okay, we don't need to shout out our numbers. After you put your title, your table of contents, turn to your next blank page and title your page Similar Shapes. So in the video, we talked about squares, and it ended with a great question that Ms. Shaver said, will this work with triangles? So here I have 3 triangles. Alright, so take a look at these 3 triangles. And raise your hand, tell me what is the same about these 3 triangles. What's the same? Parker.
They all have right angles.
Do you guys see how they each have a right angle? That's correct. What else is the same? Madeline?
They have 2 acute angles.
And they have 2 acute angles. What is the name of all 3 of these triangles? Sarah?
A right triangle.
Hey, they are all 3 right triangles. What is different? Tucker?
They're different sizes.
They're different sizes, and what makes them have different sizes? Because we said they have the same angles. You do know. Well, keep thinking about it. Okay, Dustin? Length. Remember, we can call or we can name a triangle by its angles or by its length. So just looking at these, I mean, obviously this one has a much shorter length, right? Okay, but do you see how their angles are the same size? Okay, so they have different lengths. Owen? Well, that's not really referring to the shape, but their colors are different. Caleb? Ooh, very good. We can tell that this one covers more area than the other 2. I like that one. Tucker? Their perimeter is different. Very good. Okay, so in your notes, for similar shapes, if a shape is similar, it describes the relationship when polygons have the same shape but are not necessarily the same size. Alright, so let's write that down. So, describes the relationship Okay, so when we say things are similar, like, that's you, just in our everyday talking to each other, we might mean that they're kind of alike. In math, when we say two things are similar, we mean alike in this exact way. So two polygons have the exact same shape, but they might have different sizes. Okay? So in math, we're really saying exact in this way. So these are similar because they are exact in that they have the same shape. They're all right triangles. Okay? So in your notes, go ahead, just draw two of the triangles. And since they're right triangles, it might be easy to just freehand. Yeah, just do two of them. Two right triangles, but make them different sizes. So I just kind of sketched those two. Kind of supposed to be done. That was a really good strategy. Good job. Okay, so how do we know these two are similar? And you can look at your definition if you need to. Keegan? Okay, so underneath I'm going to write these two shapes are similar their angles are the same size So, make sure you write that sentence up there. So, leave your notes open. Let's say I have this shape, and then I have this one. Is this shape similar to this shape? Why or why not? What do you think? Mason?
So in the video, how you added a square and then another square, some people said it was similar, but there was really two instead of one.
Okay. Yeah, I think they knocked on that door. Guys, you don't have to knock on that door. It's always open. You can come get your paper. It's fine. Alright, so what Mason's saying is on this side, do you see how there's one? On this side, we doubled it to two, but this side, there's one. We didn't double this side. Okay, Josh?
But some of it's still the same and some of it isn't the same. Like they still have right angles.
They still have the same angles, don't they? Tucker?
They're still rectangles, aren't they?
They are still rectangles. What do you think? Okay, so if I was going to make this a similar shape, I would have to do what Mason said, and I would have to double both sides. Okay? And the reason is yeah, this is still a rectangle and this is still a rectangle, and they both have the same angles, but they're not really the same shape, okay? Because we want to make this shape only bigger. And when I look at this shape, isn't this side clearly longer than this side? So we're talking about the shape. And the way it is here, what shape is it now if all four sides are the same? It's a square. But this shape, this side's longer. They're both rectangles, they're both quadrilaterals, but we've changed it to be a square. This shape is a square. So we want to make sure that it's really the original shape blown up. Does that make sense? So, alright. So today what you're going to do is you're going to be using Power Polygons, and you're going to be exploring similar shapes. So, quiet please. Tear out Unit 5, page 49.